Everyone, I Puneet Upadhyay, handling the subject Computer Integrated Manufacturing. In previous session, that is session 1, we have studied what is a CNC, what are the basic design factors involved in designing the machine structure of a CNC machine. In that we have studied what is the static load, the dynamic load, the thermal load and different types of guideways. So in this session, that is in session 2, we are going to study what is a feed drive, the spindle bearing, the measuring system, the gauging, the tool monitoring and most likely questions for the examination. So before starting the feed drive, let me tell you what is a drive in a CNC. CNC requires a wide range of spindle speeds and table movements in order to perform various operations. This drive controls motion of spindle slides as per the command. So in CNC, the drive plays an important role in order to control all the movements. So next comes the feed drive. Feed drives are the system which provide linear motion to the slides as per the command of a CNC system. There are two types of feed drive. One is a servo motor, second one is a mechanical transmission system. So now next is a servo motor. So what is a servo motor? Servo motor is a motor which responds to the error signal abruptly and accelerate the load quality. This servo motor works in a closed loop control system. Next, the servo system block diagram. In this you can see the input, the error detector, the amplifier, the servo motor, the feedback loop and the output. The reference is given by the input which is passed to the amplifier. The amplifier controls the speed of the servo motor. The feedback is mounted on the machine which is an encoder. This device changes mechanical motion into electrical signal and is used as the feedback. The feedback is sent to the error detector which compares the actual operation with that of a reference input. If there is any error, the error is fed directly to the amplifier which is used to make necessary corrections in the control system. Then the corrected error is fed to the servo system for the required output. So this is the working principle. Next, let me show animation video on working of the servo.
This industrial robot needs a drive with particularly high demands. Not only does the robot have to be able to accelerate and decelerate fast, also precisely positioning is required. In fact, here is a 3-phase servo motor installed. In this video, we will clarify the term servo motor and servo drive in general, then the 3-phase servo drive. The servo motor is a part of a servo drive, whether brushless DC motor, synchronous, or a robust asynchronous motor. But one thing in common is the detection of the rotor position by a sensor. This can be a resolver or an encoder. In this case, you see an incremental encoder. This sensor device gives feedback to a controller to keep, for example, the rotational speed or torque constant, or to reach the target position as fast as possible. The servo motor system includes the servo motor with its feedback device, a servo amplifier, and a controller. But how do these devices work together? The servo controller sends low voltage control signals for position, speed, or torque to the servo amplifier. Now these commands are amplified up to high power, which the motor can use. The electrical pulses of a sensor are sent back to the amplifier. This amplifier uses this information to control speed and rotor position. The job of the servo motor controller, also named as the motion controller, is to close the loop on the system by constantly interchanging data with the servo amplifier. The motor parameters like torque, speed, or position can be adjusted immediately. Some manufacturers offer modules which combine the controller and the amplifier, so you would have fewer parts, fewer connections, and a smaller footprint. Talking about an AC servo motor, you usually mean a 3-phase synchronous motor whose rotor field is excited by permanent magnets, so you get a very powerful and brushless motor of small size. The stator winding produces a rotating magnetic field, whose rotating speed and force is controlled by the amplifier and controller. In order to position quickly, all these motors must have a low moment of inertia, which can be achieved by an elongated shape. The functioning of a synchronous motor was already explained in another video of our Learn channel. Please check our playlist.
Next, the types. There are two types of servo motors. First one is DC servo motor, second one is the AC servo motor. Next, the mechanical transmission system. So what is mechanical transmission system? It is a linear motion drives which are used to convert rotary motion into the linear motion. The conventional threads forms like V or square are not suitable in CNC because of their high wear and less efficiency. Therefore, the CNC machine employs the ball screw for driving the workpiece carriage. This drive provides backlash free operation with low friction wear characteristics. These are efficient and accurate in comparison with that of nut and screw drives. Most widely used linear motion drives are the ball screws. Now next we explain about the recirculating ball screw and nut. So this is a figure related to the ball screw and nut. So this is the carriage, this is the ball return chalan, the spindle screw, the recirculating balls, and this is the nut. So here let me explain the working principle of recirculating ball screw and nut assembly. So first here in this, it consists of a screw spindle, the nut, the balls and integrating ball return mechanism. The flange nut is attached to the moving part of a CNC machine tool and the screw rotates. The nut translates the moving part along the guideways. So this is the screw. So the next, the recirculating parts play that role. When the screw shaft is rotating, the steel ball at a point A travels in 3 turns on the screw groove. So this is the groove, rolling around the grooves of the screw shaft, and the ball nut eventually reaches the point B. Then the ball is forced to change its pathway at the tip of a tube. So this is the tube, passing through the tube until it finally returns to the A. Whenever the nut strokes on the screw shaft, the ball repeats the same recirculation inside the return tube. So this is the working principle. Next, let me show the animation video on recirculating ball screw and the nut. Next is the spindle bearing. In that we explained about the hydrodynamic bearing. So this is the figure related to the hydrodynamic bearing. In this you can see the bearing, the journal, the lubrication in the yellow, then the attitude angle. So in hydrodynamic bearing, the gap is generated dynamically by the bearing motion. The hydrodynamic bearing are used in rotary applications and may require external pressure on one of the bearing pads or secondary bearing to avoid excess friction when they starting rotation. Hydrodynamic bearing can be designed for radial or thrust load. A hydrodynamic bearing is typically a low clearance assembly that relies on the film oil. So this is the oil which develops the pressure on the journal with the help of the bearing assembly. Okay, when the bearing starts rotating, this lubrication oil develops the high pressure on the journal, which makes the journal to the rotate. The bearing transmit the load on self-renewing film of the lubricant. So this is the working principle. So next is the hydrostatic bearing. The main difference between the hydrodynamic and the hydrostatic is that the hydrostatic bearing uses the external force such as pump to pressure the oil into the shaft. So let me explain the working principle of a hydrostatic bearing. A hydrostatic bearing employs a positive pressure supply that maintains clearance between the rotating and the stationary element. With a hydrostatically lubricant bearing, the lubrication is introduced under pressure between the moving surface. So here you can see this is the shaft, this is the clearance, okay, and this is the bearing. So here this is the oil inlet, the oil passes into the inlet, then it is maintained into this gap between the shaft and the, that is a bearing. The hydrostatic bearing spindle features high stiffness and long bearing life and are often used for fine machining and finishing. They can also provide large direct stiffness as well as damping coefficients. So this is the working principle of hydrostatic bearing. So next is the measuring system. What is this measuring system? The measurement system is a part of a CNC system. It is used to monitor the movement of each controlled axis and to compare the achieved position with the desired positions. So in this, it is used to monitor the position of the slides on a guideways and by orienting the spindle or table and measuring systems. There are two terms in the measuring systems, that is accuracy, second one is the resolutions. So next is the types of measuring system. First one is the direct measuring systems. So in this we have the two types, that is the offline monitoring system, then online monitoring system. So in offline monitoring system, it uses the tool microscope to detect the required parameter manually. Then this is related to the grinding of a cutting edges for the replacement of a tool which are used in the CNC machine. So next comes the online monitoring system. So in online monitoring system we have the dynamometer, the amplifier, the data acquisition system and the signal processing. So what is this dynamometer? The dynamometer is a measurement for both thrust force of a control and torque produced on the workpiece. Now next, after this it flows to the amplifier. The amplifier, it amplifies the signal and check whether there is an error, and if there is any error it corrects and passes to the data acquisitions. In data acquisition all the data is collected and it is passed to the signal processing to process the desired output. So this is the working of the direct measurement system. So this is the working. Next comes the indirect measuring system. In this we have the 4 steps. The first step is the data collection. The data collection may be in the term of the signals from the sensors such as the cutting force or the vibrations. Then after this it passes to the step 2 where the analysis of signals are done. Then the extraction of feature is done to pass on to the step 3. In step 3 the tool well pattern recognition is done by the AI techniques. This AI technique is nothing but the artificial intelligence techniques, okay, which uses such as the fuzzy logic, the neural networks. Then it is passed to the last stage, that is step 4, development of the adaptive system for controlling the machining process. So this is the working of the indirect measuring system. So this is the working. Next, the gauging. So what is this gauging? As you know, the gauge is used for the inspection work. So in mechanical industries we find lot of gauging, depends upon the job nature. So basically the gauging is used for the workpiece inspection. Basically employed for the job inspection, the better quality products can be obtained by CNC through automatic gauging system. Next, the tool monitoring system. So what is this tool monitoring system? during the machining operation, the tool wear out, resulting in the low quality products, damage of the work and reduces the accuracy of the work. So this to monitor to reduce the maximum damages and to improve the quality of products, the tool monitoring plays an important role. Therefore, it is important to monitor the tool wear and the tool breakage properly. There are two types of tool monitoring system. First one is direct monitoring system, second one is indirect monitoring system. In direct monitoring system, the condition of the tool is monitored by using a touch probe, in which the probe touches to the surface to detect the edge conditions and the tool angle and the position of a tool and passes the information to the control system. Next is the indirect monitoring system. Indirect monitoring system, the condition of tools are checked by the monitoring certain parameters which reflect to the condition of the tools. So in this we have the certain standard parameters in which the given data is compared with the standard parameters to give out the required result or the output. Next, the automatic tool changer. So in CNC machine we see the lot of operations that need to be carried out. So here the tools are contained in a storage unit that is integrated with a machine tool. When a cutter needs to be changed, the tool drum rotates to the proper position and automatic tool changer operates under program control, exchanges the tools in the spindle for the tool in the tool storage unit. So it performs the required operation as per the program given. The capacity of the tool storage unit commonly ranges from 16 to 80 cutting tools. Next one is the automatic pallet changer. So in the automatic pallet changer, you can see the machining centers are often equipped with two separate pallets. The pallets is nothing but it is a storage device which can store the finished products or the required tools that need to be mounted on the tool post. While machining is performed with one pallet in position or at the machine, the other pallet is in the safe location away from the spindle. In this location, the operator can upload the finished part and then fixture the raw part for the next cycle. So these are the most likely questions for the examinations. Totally there are 7 questions. So you need to be look out for the examinations. Thank you.